Hey everybody, welcome to your Scale Models. I'm Jason, your host, and I do models. Hopefully all is well. We are going to be looking at a Nintendo Switch here in a bit. Got a little housekeeping to do first. Let's just do this right here. So let's take care of that, and I have some interesting information that I want to take a look at that was sent to me by another YouTuber on another channel. So the coder Phil over there, a lot of you come from his channel. So if you're watching this back on replay, I appreciate it. Right now I am just seeing nobody has popped in. Well, someone popped in and then they left. So alright, so what I am going to do here is I got some containers. If you guys, I have these containers here, and they have a little spot in the top here for the board and all the little bits, and then down below is the screw container and the screen and all that good stuff. So I have these little containers. Well, unfortunately, my wife could only find 2 of these containers, and I have a third switch that is currently I'm working on, and it is in the wrong box that is labeled my switch. That's where my switch goes. Hey Crazy, how's it going? So I need to grab one of these boxes. This is a 3-compartment storage box. It's got a bin there and a bin there. So what I need to do is I need to see if I can get this in there. Nope. So the fan can go in here, and the SD card, and then the rest of this can go down here in this section of it. Slide that over, and the little screws will go in there. So, and then I have this case back for my shelf over there, but we won't be complete on this without its label. So, hey Chris, how's it going? So I am going to label this real quick, and then we are going to do some cool tests here. And we are going to do some neat little testing here. Let's clear that, and then this is 1003. Nope. 1003, and we're going to print this label 3 times. So there's 1. Wow, that's too big. Hold on. Let's try that one. That's the right size. So I just got to get these labels on here because it was bugging me. I was waiting on these containers. We ordered them from Staples, and they took like 2 weeks to show up. So we have the labels made. Put the label maker back in its case. So the label maker back in its case, and we have our labels here. So we're going to stick one on the box, like so. What's that? And where is... Then I need to put a label right here. Right there. And then I need to just trim this one so it's a little bit smaller. And this one is going to go on the switchboard. So I have it labeled on what one it is. Now we're not working on this one. This one needs a USB port and an LCD connector. I do not have the stuff in for that yet. I do have something pretty cool. The the stream on the 30th is canceled. I'll probably still do something because it is my birthday, but nothing is showing up. So there we go. We have my little case. I have 3 more of these, so I can have enough cases for the switches. And that is that. So now I have some of this thermal adhesive tape. And what I want to do is I want to convert. Hey Phil, how's it going? I want to convert my little stand vise here and make it non-conductive. So what I'm going to do is I'm going to take some of this thermal tape here and I am going to cut some strips of it about that length. And I'm going to stick it on there like that, just like that, and then I'm going to cut another one. This is the stupidest tape in the world, by the way. It has no thickness whatsoever. So it's supposed to be thermal tape. I thought it was going to be like a cushy foamy stuff, but it's definitely not a cushy foamy stuff. But it will insulate this for what I am doing, so that is a bonus. So there we go. Now I'm going to take these little guys here and I'm going to cut out this circle here, this circle, this circle, and this circle, and stick these little pigs in here. Just like so. And this is hopefully going to give me an insulating layer so I can clamp my switchboard in there and be good to go. Alright, so there is my... Yeah, this tape is garbage. I don't even know why I would want to use this. I got to go... Yeah, yeah, that's what I want to do. That file that Phil sent, he sent it to me, and I want to check something out here. I'm going to be doing some cool stuff, but I want to check something here on this switch. So now that I have that thermally insulated, I can get this board out of here, and I can hopefully clamp it in this little fixture thing here. So there we go. So that, okay, maybe not. Why is that not holding that in place? Okay, well, that's a fail on these. I thought that would hold it in. Yeah, I went through a lot of that data this morning from about 3 in the morning to about 6 in the morning. So, and I plan on doing a little bit now just to check something on this switch that is not working. So let's try this method here. There we go, that's in there. So now I can put this under my scope like so, and I got my little probe thing set up so I can test it. And Just give me 1 second here. Just check something here. Okay. Okay. Phil, you're literally in chat, and I didn't understand that message at all. Okay. Alright, so now I can, if I go to this camera, there we go, we have a scope. So now I can check this, and I can come in here with my little test probe here, and I can touch various points on the board to get readings and all that good stuff. So I have that. So what I want to do is I want to take this back out of this makeshift board holder that is no longer shorting out the bottom of the board, and I want to confirm this unit here by plugging it into my meter, and it draws 350, 347. So it is drawing that many milliamps. Turn that off. There we go. So it's drawing that. It should draw that on both sides. So yep, it draws it on both sides. It's 14 volts. It's slow charge. It will not jump to fast charge for some reason. This battery is pretty full. It's my test battery. Me not being prepared, which is extremely rare, is the meter's not on. And the software's not open. So that's fantastic stuff. So we're going to turn the meter on real quick. Dump that. So yeah, I think this is going to help everybody out, Phil. I really do think it's going to help everybody out. So there we go. The meter is up. Let me just open the software. Hopefully open the software. And I have found out that I can have 2 instances of this meter software open. So that's going to be interesting in future. So if I put my meter up, there we go. So we got volts DC. If I check this battery here, I have on the battery 4 volts on the battery, so it's pretty close to charge, but it should still be fast charging. So if I plug this back in here, what? Okay, that's weird. My meter completely shut down. Okay, you guys saw this. This was literally working. What is this? Yeah, I would have credited the author too, I'm not sure. So it has been shared publicly before. Well, I wasn't going to show it on screen. Why is this all of a sudden not working? On. There we go. Let's try that. There we go. We got working. All right. So we have 331 milliamps here. So it's at 15 volts. So what I want to do is come in here. You can see that. And I want to check to see what's being put into the battery at this point. So it was at 4 volts. And it is putting in now about 4.1 volts. So it's slow charging the battery, and that is a thing at the coil. 4.2 volts at the coil. So that's about right. That's what it should be charging at. So why does this not work? It's very strange. All three chips have been changed. It does charge. It does get power. So it still does not work. But what I need to do is I need to check this LCD connector. So let me check this LCD connector here. That LCD connector looks good. So the LCD connector looks good. So I'm not sure here what is going on with this. But what I want to do is I want to check. I want to pull up this document we have here. Let's get that off for a second. Really? You can search? Wow, why didn't we ever think of searching for it? That's crazy. So what I'm going to do is I'm going to pull this up here, and we know the fuse is good. It's B key. It does charge. And it tells you where this document tells you where the voltage should be on BQ, and then it goes into the different pins on M92, where you should have pin 6 should have 3 to 6 volts, and pin 5 should have 3 to 6 volts. So we could check that, but I know that. Well, let's check that. If I blow M96, then oh well, I blow M96. So M92, I mean, I'm sorry. So we're gonna put this in our little fixture Rooney here, and hopefully this works. So I need a way to clip on ground. I think I thought this all the way through. So I need to come in here. Let's see, will this plug into there? No, that will not plug into there. So that will plug into there. So we need red probe on ground. Red probe on ground. So that will go right there. And then we need black probe on my little probing rig here. And that is going to read diode mode. I don't want diode mode. I want to measure a voltage. So let's go back to red probe up here. And black probe down here. Hey, this is all new. I'm just trying this out. I just came up with this 5 minutes ago. So right before the stream. So if this is a little bit rusty, my bad. Okay, so we have this here. Let's see if we can get M92 in shot again. Why wasn't it focused? Okay, so M92. So what I want to do is I want to see how hard it is to just touch. I believe it's this capacitor here. I want to touch that capacitor and read the voltage. And I want to touch that capacitor and read the voltage and not short them out. So let's see if I can get all this stuff hooked up at one time Well, technically that voltage should be there with just the battery, right? Yeah, you think the voltage should be there with just the battery. Yeah, I've seen people do trace repair with flat jumper wire. Oh, yeah, my bad. Yep, thank you. Okay, so I haven't really done anything yet. So I have the battery hooked up. Should this have the voltage on it? No. So is that with the charge on it? So, um, oh, you have to have the power button on and measure that voltage there. Okay, well, that is going to be an issue. So it says, put the main board back in the switch frame. You don't need to connect anything, just the battery. After connecting the battery, click on the power button. I wonder if I can just plug a power button in and test that. You think I can do that? Just plug a power button in and not put it in the housing? What do you think? Yeah, I'm in the document right now. I'm doing the document right now. Look, let's show everybody. See, I'm at this point right here. I want to check these two for voltages, but it says here that I have to hit the power button. So it says do not connect anything. Where is it at? It says you put the main board back in the switch frame. You do not need to connect anything. Just connect the battery. After connecting the battery, click on the power button. Black probe the ground and then touch pin 5. So that's what I want to do, but I need to apparently hit the power button. So you assume I could just you check the wrong side with the meter. What do you mean? Is it not that side? Where is it at? I haven't really checked anything yet. Yeah, that is the wrong side. Where is it at? It's this side. Okay, let me swing this around here. So, it's this side. Yeah, good call on that. Yep, that's a good call. So, it's these two capacitors here. And I gotta make sure I touch those without shorting anything out to ground. So that's gonna be a big ask. Okay, so what I'm gonna have to do is bend that up. And okay. Well, here's what I'm gonna do. Just to make sure I don't blow this chip. Yeah, I realized I checked the wrong I checked the wrong spot on the switch. That's what I did. So apparently I don't know how to orient things. That's the problem. I have orientational issues. So I'm going to take this non-conductive tape here, and I am going to come over here to this camera right here, and I am going to stick, make it a little bit smaller, and I'm going to stick this So now when I touch those caps, I'm not going to short it to this chassis, because that is something I would love to do on camera, is show everybody how I can short M92 to the chassis to ground again. I get to do that fun again, and then I can change M92 again, which I'm running out of chips, so I can't do that. Okay, so now I should be able to just come in here and touch this cap without having any issues. Okay, so now, okay, so let's just check it with the battery connected, because it doesn't say you need the charger connected. So let's just check it with the battery connected here. Okay, the battery's connected. Let's come in here and check. Nope, don't short anything out. Let's check this one right here. And that one has nothing. And that one has nothing. But the document says you need to have the power button connected. So I am going to fish a power button out of this unit here. I'm going to be honest with you, I've never actually taken a power button out. Anything I should know before I... No, I don't know how to orient things. Why, is something backwards? Yeah, just remove the button. Okay. Anything I need to know before removing this button? I've never taken one out. I've never had a power button come out, so... I'm gonna grab some tweezers. Oh yeah, Phil, here's those tweezers I was telling you about. Pretty good. Oh yeah, that just comes right out, doesn't it? So let's see here. I am going to put a little bit IPA. Wow, that is just right on top of my IPA. Okay, a little bit of IPA just to loosen up that glue on that power button. And it seems like it might be glued on this side too. So, what are you saying? I stick that back down with, yeah, that's going to be fun. I'm looking forward to that, Phil. I really am. Oh, don't tear, don't tear, don't tear, don't tear, don't tear, don't tear. Okay. So, there we go. Oh, come on. Come on. Don't tear, don't tear, don't tear, don't tear, don't tear. Okay, so that's that. Now let me get a little bit of IPA under this section here. And just work that around there. There, look, I pulled my first power button out. Yay me. Look at that, first time. Oh, if I can get the thing back in, that would be a miracle, right? I'm going to take this tape off because I can replace that. I'm going to use probably that B7000 to put it back in. Ooh, Phil got packages. Hopefully it's something to fix. And he doesn't have to dig around with rice. I mean, as much fun as it would be to see him mess around with a console full of rice, yeah, I'm not sure. So this goes into Damn. Okay, guys, I need some help here. On this, is the power the top or bottom one? Someone answer me, please help me. Hey RB, how's it going? Can someone tell me if the power connector is the top or bottom of these two connectors here? I don't have one to hand to look. Hey Jaden, how's it going? So, anybody know if it's the top or bottom one? I know the other one's just the fan. You don't know which one is the power connector? You're seriously gonna make me look at another switch, aren't you? Okay, let's see. Let's open up this one. You could have just told me, but no, you're gonna make me dig out another switch. So this would go in here like so. It's the top one. Alright, it's the top one. Thank you, Phil. I'm doing alright, Jaden. Phil sent me this cool document, and I just want to check some things out with it, and measure some voltages and get used to doing it. So, okay, we have a power button. We have a good battery. Let's get this back underneath the scope with the probe attachment. We're gonna probe it. Okay, so we need the battery. And now, so I have the battery. Oh my god, which one's the power button now? I'm assuming it's this one. Yeah, I'm assuming it's this one. So I want to touch this one right here. Nope, not that. Let's do this one first. So I'm touching it, nothing. Power button. We did the power button. Nothing with the power button. Nothing. Again, nothing. Yeah, that's definitely the power button. Okay, let's check this other cap here. Let me just rotate this around. Okay, so that has nothing on it. Power button. Okay, so I'm not getting any voltage on there. And let's go far right. Yeah, okay, thank you, Phil. You knew that, but you didn't know what connector it was. I'm disappointed, Phil. I already had the label maker out, so I'm not going to get it out again. So, let's see what it says. Let's go back to this view. Okay, so, since pin 5 is the input line, and follow the trace that ends up with the capacitor, you check this, you should touch with the probe. In that, you're supposed to have 3 to 6 volts. If you have 0 volts or less, you have a short on that line. Okay. Since pin 5 is the input, the short comes back from that line. The output pin, pin 6. So it's saying I have a short on that line. Hold on a second. That's written weird. Let's go back here. So if there's supposedly a short on that line, let's confirm that. Let's just check that and see if there is a short on that line. Let me get my probes here. So I'm going to go to, of course my meter is right here. I'm going to go to, let's go to diode mode. That in diode mode, I want to check this here. If I go to on ground, if I touch that cap, don't worry about the beep, guys. I have a 2 volt threshold, so it's 4 point there. I really can't see what I'm doing. I got to put this in the holder and look under the scope because I can't see. So let's get that back up. Let's put our red probe on ground. And watch it be like my ground wasn't connected or something. Red probe on ground. Could have left this all connected. So red probe on ground. If I come in here and I touch this capacitor, I get 4.2 diode reading. And if I touch this one, I get a 4.782. And you guys can confirm I'm reading the right capacitors, right? That is correct. What? Why is this not? Here we go. So, yeah, I'm definitely reading the right capacitors. So, saying that this pin 5, 1, 2, 3, 4, 5. So this is my input line right here. Disregard the beep. That's my input line. I'm getting 0.478 volts to ground. Let's go to resistance mode so I don't have to hear it beep. I could have turned the beep off, but whatever. So it's 31K. What's this one? So not having voltage when I hit the power button on that is not a short to ground on mine according to the document. But supposedly hitting the power button, I should be having voltage there. So let's swap these probes around again. Swap these probes back. Go back into voltage mode. Voltage mode. DC voltage. Confirm that it's voltage. So I want to know, is there a way? So let's plug this back in here. I can't tell if that's plugged in right. No, that's not even plugged in right. So I'm going to be honest with you guys. I'm going to be fumbling with this whole time. So because I'm going to do my... Oh, come on, seriously. Okay. Why is that not locking in? So now, if I plug, first, let's find where our, we're assuming that is going to short. When you press the power button, you're going to short something to ground. That's what we're going to assume. So we are going to touch, we're going to spin this around, and we are going to touch one of these pins here and find out which one is ground. So, is it that one? Alright, nope, that was not ground. Is it this one? That one? Nope. Is it that one? Nope. It's this one. Yep, that's the ground pin. Now, technically, if I hook up the battery, there should be voltage on one of those lines, because it has to have a voltage to short the ground. So if I come back up here to voltage mode, okay, hopefully you guys are not talking to me. Let me check this chat real quick because I got into this. Oh, you got that laser quick, Phil. Okay, so thanks for not paying attention. Power supply. Oh yeah, I remember. Yeah, Phil had shorted APU. Alright, Jaden, okay. It was probably blurred. I'm sorry about that. Okay, 1 p.m. I wish. Okay, hey Jay, how's it going? Alright, so I caught up on chat. So technically I should have a voltage on one of these pins that is power with the battery connected. So we know that that one is ground. So I don't need to check that one. So if I come up here and I plug my battery in, I should theoretically have voltage on that power pin here. So if I touch that, and I do, I have 3.9 volts on the power pin. Look at that. I learned something. What is this one? Volume button has nothing. And this should be a volume button here. That will have nothing because it's not turned on. So that confirms I have power going to the power button. So what does that tell us? So I have power going to the power button. I have charging circuitry. It definitely charges. So let's go back up to our thing right here, and it says pin 5 is the input voltage pin when it is turned on. So we are going to check this one more time that we know the power button is getting voltage. So if we come here like so, and we put our probe on this right here, and we press the power button, that should signal we get a 3 to 6 volt input voltage. And we are not getting that input voltage. Okay. And what about here? Okay, so, but we have power distribution through the board from the BQ chip through M92 because it charges. It gives me power to the power pin. So we have power going through the board, but it is basically nothing's happening when the power button's pressed. So And I assume when I press the power button, it is actually shorting that power button to ground. I will check that in a second. Let's check that. Let's just confirm that when the button is pressed, it does indeed short it to ground. And there is a easy way to do this without adding voltage to the mix. We can just come here, go back into resistance mode. I can find my cursor, go back to resistance mode, and if I grab the power button and I come to the power pin here and I get megohms, if I press the button, I get 0 ohms. So the button's working. It's definitely shorting the button to ground. So shorts it pretty hard to ground too. So that's the third M92 chip. So I'm not thinking it's M92 anymore. This is odd. This is truly odd. And now, what I want to know is if you have the wrong NAND, it doesn't turn on normally unless it's a blue screen, and then apparently it lights up blue screen. So I wonder if it doesn't put power on that output line. Okay, so yeah. Okay, so apparently pin 2 on M92 will boot loop you because it's an analog test debug pin 2. So that would be an issue. That's where it gets the data from the battery, battery health and stuff. So that's pin 2. And it goes in the check-in pin chip P13 USB. Okay, well, that didn't give me the information I was hoping. Streaming early today, and then Monday I have 2 PS4s coming in to stream. Hey, that's good. You finally got something. I know you've been dead and you haven't had a lot, but the rice-filled Xbox, that's going to be interesting. So I am out of ideas of what I'm going to try today. Oh, I was hoping that I would get that output voltage and it would be something else. So something is not negotiating with M92 from the power. So the power button shorts to ground. I wonder what signal, I wonder if it's on here, what signal does M92 get to turn the console on? Like where does that line go? let's check these resistors right here. Let me zoom in on this here. Alright, if you look at this, yeah, definitely need. Oh, you guys aren't even talking to me? Are you guys even paying attention? So there is two resistors near the power connector that control the power connector. And I'm assuming they're the ones that get grounded to send the signals. So I'm assuming this one's going to be power. So I wonder if that resistor gets blown, it doesn't send the signal to the connector. So let's see here if we can measure the resistance of these resistors. So I'm going to grab these because they're closer. You know, yeah, I'm going to grab these. I haven't modified the tips on my other ones yet. So I'm going to grab these LCR tweezers here. And I'm going to measure the value of these resistors if I can find them on the scope cam again. So I want this one right here. That's 100K. That's what it's supposed to be. And this one right here is... Okay, that's weird. $149 ohms. 150 ohms. Oh, it's supposed to be 150 ohms. Okay, so that one's right. Why is this one so much larger in value? Am I reading the right resistor here? Yes, this one. This one is reading... Oh, wow, I'm stupid. That's reading 150K. Oh yeah, I'm sorry guys, you can't even see the meter. Look at that. Need LCR tweezers on the screen. So if I come in here and I measure this, it's 150 ohms. And if I measure this one right here, I'm not going to be able to see this. It's still 150 ohms. Okay, so that is, those are correct. So why can't I find it? There we go. So those resistors are correct. So hey Reese, how's it going? Alright, so I'm going to back out of this now. Okay, so we got a bunch of values for stuff. Oh, we even got the part numbers for the Molex ribbon connectors. Okay, now we have a bunch of stuff that corresponds with cluster A. This clusters different things. This is a pretty neat section here. This is all the different, this is the back side of the board, all broken down, and then there's the SD card. But he has all these named as clusters, and a lot of them have UART output on it that I can capture with the scope. So I'm not going to go through all these test points on camera, but I am going to check all these, and then I will do a video to update if I find anything. Because this is insane amount of stuff to check. This is supposed to be where all your voltages are, so I could check that later. Okay, so let's go back to this view. So, faulty televisions. I don't think Phil would like a television because it's a lot of time the power supply, and he doesn't like to mess with the power supply. I built and designed power supplies, so as long as you discharge the capacitors, you are good to go. And don't touch it. If you don't touch it ever, you're safe. That's a rule of thumb. If you don't ever touch it, you can't be shocked. So that's just it's just a rule of thumb, guys. If you're messing with a power supply, if you don't touch anything, you're going to be perfectly safe. So it's just a bonus. I should make a label that says that. So just like if you don't want to mess it up, don't touch it either. So it's just rules of thumb when fixing things. So I am going to call it here another hour. That's about as long as I stream. So I'm going to check a lot of this stuff off camera, maybe film a little bit of it and do it in an update video. This is a ton of information, and being stuck on the first page, not getting that input voltage when the power button is pressed, I need to dive into that a lot deeper, and it would just be a bunch of dead space with me not talking for an hour, and that's not cool. So yeah, it's awful. I mean, yeah, I've got a habit after getting shocked 50 or 60 times. You get into a habit. It's like before I touch it, I discharge all the capacitors. Like I have a box that has a red and green light. I put the probes across all the capacitors until the light's green. When the light's green, they're dead. So if the light's red, you definitely don't want to touch it, and then you wait till the light changes colors. Yeah, you can short them out with a filter driver, but I worked on three-phase DC power supplies. It was three-phase converted into DC power, and that's a lot of voltage and a lot of amperage. So if you short those caps out with a screwdriver, you're going to blow a hole in the board. So you have to discharge them slowly through about 20 meg ohm resistors. Sometimes more depending on the size of the cap. But it's a good device to have it. It's good practice just to always discharge capacitors. DC voltage? No, it's way more than that. It's like 780. Well, here it's like, in the US, it's like 400. 480, 510-ish, depending on how much you lose in the capacitor you clip the voltage with and all that. But the UK three-phase is 800 or 900 volts. So DC, so yeah, you don't want to put a screwdriver across a capacitor that has that much voltage in it. So yeah, so hey Andy, how's it going? Don't mess with me. Yeah, it's just, I don't know, when you had to do it for a living, you really don't have a choice in the matter. If I had a choice on a console where it was cheaper to replace it than fix it, I would replace it. I wouldn't mess with fixing it. If you don't have to mess with it, then don't mess with it. But if you're in a bind and you need to fix it, then I'll fix it. But I'm not gonna mess with something that I can easily replace. So, and especially if you're not if you're never comfortable with electricity, don't mess with electricity, no matter what it is, because you can get hurt. Even low stuff can hurt you in different ways. So I've seen, well, actually it was like 300 volts DC, but I saw some people get some nerve damage in their hands from DC, but it was like 300 volts DC, so 5 volts DC is not going to hurt you. So, yeah, yeah, and you say they're pretty cheap. I mean, I've never bought a PSU, um, you know, live, well, I don't know, 240 volt, what is it, max 13 amps with your guys's, after the breakers and stuff? Because I know you have 13 amp fuses in the plugs. What's the amperage at the breakers? Yeah, I mean, troubleshooting the DC side of a power supply and learning how power supplies work gives you a lot of fundamentals in electronics, because a lot of stuff that learning about switch mode power supplies and linear power supplies, a lot of the DC to DC stuff um, carries over into other types of circuits and things like that. 40, okay, 40 to 50 amps, okay. Um, yeah, that's pretty big. Wow, only 40 amps in your workshop? That seems a little low. Hopefully you put two 40s in there when you do your new workshop fill, because I don't have a rework machine or anything like that, and I got 60. And I'm about, you know, with everything running, I'm fine. But I don't know if I put a rework machine or fired up some machinery if I could run multiple things at once. So, yeah, I don't know. That's weird. I don't know. With the 240 volt, it's different too because it's more power. So, I would think you would use less amperage to power something than we would use it over here. So, alright, guys, I'm going to call it here. Thanks for stopping by. I appreciate it. Sorry we didn't get anything, but we did learn. So, that's more important. That's what I care about, is the learning process. So, I am going to create a searchable spreadsheet, and I'm going to start working on that. So, thank you guys so much, and I hope everyone has a fantastic day. And don't forget to watch Phil mess around with rice later, because that's fun.